Exercise 8.1, problem 13, discussion. Let's read the problem. A heap of paddy is in the form of a cone whose diameter is 4.2 meters and height is 2.8 meters. If the heap is to be covered exactly by a canvas to protect it from rain, then find the area of the canvas needed. Okay, so now let's mark all the information which is given in the problem. 4.2 meters, that is nothing but the diameter. Shape is cone. Okay, 2.8 meters, that is the height of the cone. Okay, anything else is given? I guess that's it. So it's a cone of diameter 4.2 meters and height of 2.8 meters. Let's write it here. Diameter equal to 4.2 meters implies radius is 2.1 meters. As I've been telling you, please do this step immediately. Otherwise, we will be going and substituting diameter in the place of radius and you will be getting a wrong answer. Okay, radius equal to 2.1 meters, height equal to 2.8 meters. Next, what are we asked to calculate? If the heap is to be covered exactly by a canvas to protect it from rain, then find the area of the canvas. So this is what we are asked to calculate. Okay, let's look at the figure also. So this is the cone, the heap of paddy in a conical shape, and this they want to cover it by a canvas to protect it from rain. So which means the side area, this is what is required. Okay, because the bottom is in touch with the ground, so that is not to be covered, and this normally they keep it at a slope, so water will not go there, water will run down. So this, the whole of the side needs to be covered. What is that? That is nothing but the curved surface area of the cone. That gives us the area of the canvas required. Okay, so instead of giving you or asking you directly, they are giving that information, or they are asking you indirectly. Okay, so we are asked to calculate the area of the canvas. So let's list the formula. As I told you earlier, it is the curved surface area which gives you the area of the canvas required. Okay, so CSA equal to pi RL. But you see, we will not be able to calculate it because we don't know the slant height. Only height is given, slant height is not given. So we cannot calculate CSA. We have to do something else. So let's see what else is given. Okay, so we'll have to calculate L. The formula for the L is slant height is root of radius square plus h square. We know radius, we know height. So which means using this formula, we'll be able to calculate slant height. And once we know slant height, you can go ahead and substitute that value of radius and L here and calculate CSA. So I've been telling all these things right from the beginning. So start from what is asked. So in this case, area of canvas is asked. So write the formula for that. And if you can calculate one of these variables here, and then keep writing subsequent formulas to calculate those unknown values, and you'll be able to solve the problem. If you have that approach, then the problem becomes very simple. Okay, so let me summarize the steps. Substitute the value of radius and height. Radius is 2.1 meters, height is 2.8 meters in L equal to root of radius square plus h square and calculate slant height. Okay, next. Substitute the value of radius and the slant height in the formula CSA equal to pi RL. L we have calculated here in the step 1, and calculate the CSA. This is nothing but the area of the canvas required. Okay, quite simple, isn't it? So try this problem, pause the video and try to do this problem on your own. Okay, the solution. Diameter is 4.2 meters. We are converting it into radius 2.1 meter. Height is given as 2.8 meters. The area of the canvas required is the CSA. Okay. So the first step is to calculate the slant height. Slant height L equal to root of r square plus h square. That is root of 2.1 square. The radius is 2.1 here. Plus h square, that is 2.8 square. That is 4.41 plus 7.84. That is 12.25. That gives 3.5 meters as the slant height. Please try to do this calculations on your own. Okay. Now area of the canvas needed is the CSA of the cone. So write the formula for the CSA of the cone. CSA of the cone is pi RL, that is 22/7 into radius is 2.1. Slant height we have calculated here as 3.5 meters. Substitute that here. So 7 will go here 2.1, 0.3 times 0.3 into 3.5 is 1.05. So 22 into 1.05. So that gives us 23.1 square centimeter. So area of the canvas needed is 23.1 centimeter square. Okay, so it's quite simple. Needs little working, but it is easy only. I hope you have got this problem correctly worked out, and if not, please check where you have gone wrong and try to correct it. And if you don't understand the concept, please go back to the discussion part of the video and try to understand the steps and work it out. Okay, thank you for watching.